In this presentation, I'd like to address the puzzle of consciousness. And to see why consciousness is such a profound puzzle for modern science and philosophy, we're going to play a little game that involves some easy and hard thinking. I'm going to call the game the This Is That game. So here's our first This Is That. A lot of trees in close proximity is a forest. This is that. And so here we see a picture of a forest. Now, on a scale of easy thinking and hard thinking, for a lot of people, this might be pretty easy thought to get our head around. You get a bunch of trees close together. We call that a forest. A collection of water droplets in the air is a cloud. Again, not really that difficult to get our heads around. 200 billion stars gravitationally bound together is a galaxy. Again, while it is a majestic cosmic structure, intellectually not hard to really comprehend that a galaxy is a bunch of stars gravitationally bound together. The set of all points on a plane equidistant from another point on the plane is a circle. Again, we can sort of understand. You take a point here and then you draw all the other points equidistant on the same plane and you got yourself a circle. A giant compressed cloud of hydrogen gas undergoing nuclear fusion is a star. And there's a picture of our sun. Now here, if we're not familiar with some of these objects, it might be a little new, and that might increase the level of difficulty of our thinking to really comprehend what these things are. The rapid oxidation of wood is a fire. Again, we might not be familiar with sort of chemistry, and so now we're starting to get into things that might be a little bit harder to understand. The average kinetic energy of particles in an object is its temperature. And so if you have low kinetic energy of the particles in the object, it's going to have a low temperature. And if the objects are moving around a lot, they have high kinetic energy, then the temperature of that object will be higher. Again, this takes some getting used to. Here again might be a little more challenging. A self-sustaining chemical reaction capable of Darwinian evolution is life. Here we see some single-celled organisms, an amoeba here and a paramecia, and here the amoeba is engulfing its prey, the paramecium. So this is pretty profound stuff here. This sort of definition of life might be hard to really grasp without further study. So we've seen some easy examples of this is that, and then progressively perhaps they've gotten a little more challenging. Well, here's the one that is really challenging. Electrical activity in a network of brain cells is a conscious experience. And we've used this video, and we'll play the video here in a moment, to illustrate what brain cells are doing in a brain. They're generating electrical signals. Now, these neurons have been genetically engineered to emit light when they generate electrical signals. So it's just a way to visualize the electrical activity of a population of brain cells. But this is what's happening all over our brain. Individual neurons are communicating with each other, generating electrical signals and triggering electrical signals in a neighboring neuron. That's what brains are doing. Now let's take another crack at this puzzle here. So here we've got our brain, we've got the left hemisphere here, and we've got the touch and the visual and the auditory cortex here, and then our working memory system here. And we've learned in the past that when we're having a conscious experience, the areas of the brain that are processing the sensory aspects of the event are sharing information with the working memory system, and then the working memory system is rebroadcasting that information back out to various parts of the brain. But that seems to be correlated with our conscious experience of the event. So the visual cortex is processing what the tiger looks like, the touch cortex, what it feels like, the auditory cortex, what it sounds like, and we're having this unified tiger experience, and we're conscious of it. But if we were to examine somebody's brain and monitor the activity of neurons, we're just going to see in the visual cortex, we're going to see a population of neurons being turned on. by the presence of the tiger. In the touch cortex, we're going to see a population of neurons that have been activated by the feel of the tiger as we pet it. And in the auditory cortex, we're going to see a population of neurons that's activated when we hear the tiger roar. So notice, there's a puzzle here. So if we take the visual system, in the visual cortex, the activity of those neurons just doesn't seem to be the same thing as what a tiger looks like. The activity of the neurons in the touch area doesn't seem to be the same thing as what a tiger feels like. And the activity in the auditory cortex doesn't seem to be the same thing as what a tiger sounds like. To take it one step further, we can go up to the frontal cortex here in the working memory systems, and we can look at what's going on there. And again, we're just going to see a population of neurons that are being activated by the regions of the brain in the back half of the brain here. So, but that activity in the working memory system doesn't seem to be the same thing as our conscious experience of what a tiger looks like, feels like, and sounds like. So what a puzzle this is, that a dynamic pattern of neuron activity somehow generates a conscious tiger experience. Nowhere in the brain is there anything that looks or feels or sounds like a tiger, and yet we're having that conscious experience. That's a deep puzzle. So we can call that the puzzle of consciousness. Now, another way to approach this is to think about individual neurons. Of course, brains are made of neurons. And scientists do not think individual neurons are conscious. These are non-conscious biological living cells. Of course, they're hooked up into complicated networks and so on, but brains which can give us a conscious experience are made of units, neurons, that are not themselves conscious. So imagine we are standing on the shores of Maui, and we're looking off into the distance, and on a beautiful moonless night we see the Milky Way on the horizon. So imagine this is the brain of a person, maybe ourselves, who is seeing this sight. All right, so the brain is processing this experience right here. And now imagine we could shrink ourselves down to the size of neurons and enter their brain. So here we are. The person is actually seeing the Milky Way, but now we shrunk ourselves down to the size of neurons, and we're just looking at the different neurons in some different areas of the brain. And so we just see a pattern of neural activity. Certain neurons are being turned on, others not. It's a dynamic pattern of activity. But remember, what the person is actually consciously seeing is the Milky Way. So how is this possible? How can neurons, each of which is not conscious, produce a conscious experience? It is a deep and profound puzzle that modern science and philosophy is grappling with. Now I'll leave you with one final profound thought. However it occurs, with the emergence of consciousness, the universe can know itself.